All right. To finish these couple proofs out that we need to look at, let's go ahead and do that. So in proof number 4, we are given that segment FR is congruent to segment AN. We know that our given statement is always going to be our first statement. So let's write that first. I also know that what I'm trying to prove is always going to be my last statement, so we can go ahead and fill that in as well. Okay, so let's go ahead and take a look at statement 1 compared to statement 2. We're told that segment FR is congruent to segment AN, and then in statement 2, we see that the length of FR is equal to the length of AN. Going from the segments are congruent to their measures are equal. This is our definition of congruent segments. Okay, we use that quite a bit in class today. Number 3 says the length of RA equals the length of RA. We have the same thing on both sides. Hopefully we can recognize that as our reflexive property. Okay, now coming to statement 4. If you look at statement 2 compared to statement 4, you might see that we have FR on the left-hand side. We have AN on the right-hand side. What's different is that we are adding on the length of RA to both sides of this equation to make this one. We add something on to both sides. That is our addition property of equality. From there, FR plus RA equals FA. The part plus the part equals the whole. That is our segment addition postulate. Similar for number 6, it says AN plus RA. So AN plus RA equals RN. Again, the part plus the part equals the whole. That's another segment addition postulate. All right. Then finally we get down here. So this one takes a little bit of work to see because it uses all of these statements together to get down to number 7. In statement 4, we said that FR plus RA equals the other side. Well, if you see that right here, notice that that's equal to FA. So we're taking that and replacing FA. We said that AN plus RA, right here and here, is equal to RN. So I'm replacing RN into that. So that is going to be substitution. And then finally, going from measures are equal to the segments are congruent is our definition of congruent segments. All right, and the last one, it says bonus. This one's a little bit tougher, but I still know that my given is my first statement. And it says that Q is the midpoint of PR. So what we have to think about is, what is a midpoint? Well, the midpoint is the point directly in the middle of that segment. So if Q is the midpoint, that means this and this are the same. So we can say that the length of PQ is equal to the length of QR. That's what we call the definition of midpoint. on the next one, and there's a little typo. This should be PQ plus. PQ plus QR equals PR. So the part plus the part equals the whole. That is our segment addition postulate. And then we have PQ plus PQ equals PR. Well, if you notice in statement 2, we said that PQ is equal to QR. So what I'm going to do is take PQ, substitute it in for QR. That's how we get to PQ, so that is substitution. Combining the 1 PQ plus 1 PQ into 2 PQ, that is actually the distributive property. It's kind of the backwards of the distributive property. It's kind of going backwards. And then you can see that we need to use the division property twice. So first I'm going to divide both sides by 2. That gives me PQ equals PR over 2. And then I would disagree with this last one. I agree with that being division, but if I want QR equal to PR over 2, and I know that PQ and QR are the same, I would say that's substitution. So I disagree with that a little bit.